All right, here's the next skill. We now know what molar mass is, and you know how to calculate it. Well, in chemistry, we are able to measure masses in the real world. We have mass balances. We could, have a measure of a salt, for example, and we could measure what its mass is. But then we want to do things with that value. We want to figure out maybe how many actual compounds of salt are there in that mass. Well, we need to be able to figure out how many moles there are first. So this is where molar mass is useful. It bridges the gap between mass and moles. It is in itself, molar mass is a rate. It's a quantity of mass per 1 unit of mole. So there's a relationship between mass, and the symbol we use is little m, moles, the symbol is little n, and molar mass, capital M, which you saw in the last lesson. So you know that molar mass is mass per mole. Well, here's a relationship between 3 variables. There it is. Molar mass is equal to the mass divided by the moles. Well, this can be arranged into 2 other relationships. Moles is going to equal mass divided by molar mass, and mass is going to equal moles multiplied by molar mass. And as long as you know 2 of these variables, you can figure out the third. So let's go through this example. We want to convert 2.5 moles of calcium carbonate into mass. Well, first thing I had to do was figure out what the proper formula of calcium carbonate was. So Ca 2 plus, CO3 2 minus, 2 plus and 2 minus balance, so we need 1 of each. Then I would always suggest that you make a list of your knowns and unknowns. This is going to help you figure out the answer. So mass, well, we don't know. That's what we're asked to find out. Moles, we are given that, it's 2.5. Now I want you to notice that in this question there is 1 quantity given. Here it is. This has 2 significant figures or 2 significant digits. I switch those words around all the time. Our answer cannot be more specific than this measurement. So our answer has to have 2 significant figures. When you put numbers into a calculator and you multiply, you divide, you do all sorts of things, your calculator could give you 15 decimal places. But it is not proper science to report an answer to that specificity. We are limited in our answers by what our original measurements were. So you always look to see your original values you're given, look to see how many sig figs are in that value, and then generally that's the number of sig figs your answer has to have. So we know moles, we don't know mass. Well, we can always figure out molar mass. So that was the skill in the last lesson. So 1 calcium, 1 carbon, 3 oxygens. I sub those values in, I add them up, 100.09 grams per mole. All right, so now I'm going to write down the relationship. Mass is equal to moles times molar mass. There's our moles, there's our molar mass, and a mole divided by a mole cancels out. You can think of this as a fraction over 1. Grams is in the numerator, which we want because that's the unit we're looking for. So 2.5 times 100.09 gives us 250 grams. So our answer needs 2 sig figs, and this does have 2 sig figs because this 0 is not significant. Now you always want to ask yourself, does my answer seem reasonable? Because generally in these types of calculations, you're either multiplying numbers or you're dividing them. And if you do it correct, then your number makes absolute correct sense. If you do it incorrect, then your answer makes no sense at all. So think about it. We were asked to find the mass. We had 2.5 moles. 1 mole has a mass of 100 grams approximately. So would you expect to get a number larger than 100 grams or smaller than 100 grams? Well, 2.5 moles. This quantity per 1 mole, we would expect a number larger than 100. Did we get a number larger than 100? Absolutely. 250 grams is very reasonable. Let's look at another example. Convert 0.500 kilograms of sodium sulfate into moles. All right, well, when I look at this number, leading zeros are not significant. This is just a placeholder. This 5 significant, and then these 2 zeros are significant. I don't have just 0.5. I know that I have 0.500. That is a specific number. We have 3 significant digits. All right, sodium sulfate. Well, needed to determine the formula to do any of this. So Na2SO4. Also, you need to check your units. Kilograms is not a unit that works in this relationship of moles mass and molar mass. We need grams. So first step is we need to convert kilograms to grams. Well, there's 1,000 grams in 1 kilogram. My units are going to cancel out. Kilograms cancel out. Left with grams, 500 grams. All right, moles, well, we don't know. Molar mass, we can know how to figure that out now. So figure out how many sodiums, sulfur, oxygen, sub in from the periodic table, add that up, 142.04 grams per mole. All right, so here's our relationship. Moles is going to equal mass divided by molar mass. So 500 grams divided by 142.04 grams per mole. So this rate is like a fraction, and for me, I have a really hard time in this format seeing if my units are actually going to cancel out properly. So I like to write it like this. I take this 142.04 grams per mole and I just I flip it like it was a fraction. And then I can see that grams are going to cancel out and I'm left with moles. So you can write it like this if you like, or you can write it like this, but as long as your math properly works out and your units properly work out. So 3.52 moles. Now ask yourself, does this answer of 3.52 make sense? We had 500 grams, 1 mole is 142. We had 500. Yes, we are going to have more than a mole, so 3.52 does make sense. If you had these numbers flipped and you did 142.04 divided by 500, you would not get the same answer, and the answer you got would not make sense when you really thought about it. So try some of the practice questions. If you're having trouble, email me and let me know what I can help you with. And as always, just do what you're able to do and try your best.